Hello, we are from Group JOCC1 and we present about major determinants affecting household consumption per capita in Malaysia between 1991 and 2021. So, let's go.
Hello, I'm Muhammad Ahmad bin Wasani and I will be presenting for the introduction parts. There is no question that the COVID-19 scenario has had an influence on global markets. It is an unusual occurrence and many people, including businesses, have been caught off guard by the way events have unfolded. For example, the global airline industry has been forced to scale back operations since people are no longer traveling and it has laid off 50% of its staff because flight operations are no longer operating owing to the lockdown enforced by all governments. Non-essential enterprises have been forced to close, including real estate, construction, automobile, travel agencies, and retail establishments. Many firms are now struggling to meet their monthly costs. To help ease the burden, Bank Negara Malaysia announced a 6-month moratorium period for loans and mortgages. However, even with lender assistance, many individuals and companies are expected to struggle to make ends meet. It is no more business as usual, and the gravity of the domino impact on the end value chains, namely homes, must be acknowledged. When people stop spending, firms begin to collapse in greater numbers. Many people have lost their employment since the firm for which they work could not afford to pay their employees owing to the losses. The COVID-19 pandemic has impacted many people, particularly low-income households.
For the problem statement, you can see declining household during the pandemic-ridden year of 2019 and 2020. So, based on the Department of Statistics Malaysia estimate in 2020, number of poor households increased to 639,800 in 2020, up from 405,400 in 2019. The purchasing power of Malaysia household consumption fell by 16.7% over a decade to 83.3% in 2020. The department also revealed that average spending on consumption is estimated to decrease by 1,922 ringgit or 48%. The expenditure of household is more focused on goods and services that are really required by the household, such as food, utilities, health, and communication. Expenditure on food and non-alcoholic beverage group increased by 27%, result from the requirement to purchase additional raw material for eat-at-home purpose. Besides that, the expenditure on education and communication group is expected unchanged. Meanwhile, the main group that record a decrease are clothing and footwear by 95%, transport 89%, restaurant and hotel 86%, furnishing, household equipment and routine household maintenance 72%, recreation service and culture 71%, alcoholic beverage and tobacco 65%, housing, water, electricity, gas and other fuels 58%, and services 39% and health 38%. The graph on the left shows Malaysian trends line for the household consumption per capita steadily increased from 1916 till 2019 before falling during the pandemic in 2020.
Our research objective is to study the effects of household income-based lending rates and exchange rates on household consumption per capita in Malaysia between 1991 and 2021.
Now, we move to methodologies. We use 6 sources and software for our research, which are Microsoft Excel, Statista, Bank Negara Malaysia, where we got the data, as well as Department of Statistics of Malaysia, the World Bank, and lastly, the EU to compute our data and get the outcome for our research. Next, we move to economic model. There are 2 functions that we use, which are general function and theoretical equation. For the general function, the dependent variable is lot consumed and the independent variable are lot income, interest rate, exchange rate, and residual. And the small p represent the time. For the theoretical equation, we use lot consumed equal to beta 0 plus beta 1 lot income plus beta 2 interest rate plus beta 3 exchange rate plus residual. These are the indicators of our dependent and independent variable. The lot consumed is the natural logarithm of Malaysia's household consumption per capita measured in US dollar. The lot income is the natural logarithm for Malaysia's gross national income per capita measured in US dollar. The exchange rate is the natural logarithm for the average annual exchange rate between ringgit Malaysia and US dollar. And the interest rate is the average annual base lending rate, and the beta zero is the constant term, and lastly residual is our error term.
Moving on to our much anticipated findings and discussion, how good is our model and what have we learned from the analysis? Let's take a look at our multiple regression output generated from eViews. We have used the ordinary least square method to estimate our double log model, where consumption, income and exchange rates are in natural logarithms. The constant term of negative 4.2994 is the value of y when all the x's and the error term are equal to 0. Coefficient for log income is positive, while the coefficients for log INTR and log EXRT are negative. This gives us an indication that income has a positive relationship with household consumption per capita, while interest rates and exchange rates have a negative relationship with household consumption per capita. Given the eViews output, we can now establish an econometric model, also known as the estimated model, to estimate quantitative changes in one variable as a result of a change in another variable. The estimated model is shown here without the error term, also known as the residual. The difference between the observed value of y and the value of y predicted by the estimated regression equation is what's called the residual. The least squares method that we use chooses the parameter estimates such that the sum of the squared residuals is minimized, hence the exclusion of the error term in this estimated regression. Now that we have derived our estimated model, let's delve into how we interpret the slope coefficients in this model. To begin with, what are slope coefficients? A slope coefficient indicates the change in the dependent variable associated with a 1 unit increase in one of the explanatory variables, holding all other explanatory variables constant. Considering that our model is in double log form, we will interpret the slope coefficients in percentage changes. Starting with the coefficient of log income, the model suggests that a 1% increase in household income per capita will increase household consumption per capita by 1.441%. Meanwhile, a 1% increase in the base lending rates issued by Bank Negara, or we call it simply the interest rates, will decrease household consumption per capita by $1,096. On the other hand, a 1% increase in the exchange rates between Malaysian ringgit and US dollars will reduce consumption, or primarily imports, by 0.241%. The next component we will look at is the goodness of fit. This is basically a statistical test that determines how well our sample data fits the distribution from a population with a normal distribution. In other words, it looks at the discrepancy between the observed and expected values in a normal distribution. For the goodness of fit in our model, we will use the adjusted R-squared value given in our multiple regression output. From the figure on the left, the adjusted R-squared value suggests that 97.19% of variation in household consumption per capita can be explained by the independent variables, while the remaining 2.81% of variation is explained by other variables that are not captured in this model. The adjusted R-squared looks at whether additional input variables are contributing to the model. Given our very high adjusted R-squared value, it gives us an indication that the additional explanatory variables are actually adding value to the model because they are able to explain well the corresponding changes in the dependent variable. Therefore, we can say that the model is a good fit.
For the Determinants test, we use Jar-Bera test. The Jar-Bera p-value is less than 0.05, therefore it is not significant at 5% significance level. However, the p-value is greater than 0.01, therefore we do not reject the null hypothesis at 1% significance level and conclude that the residual for a normal distribution. The variant inflation factor for log income, interest rates and exchange rates are all lower than 5. Therefore, we do not reject the null hypothesis and conclude that there is no multi-collinearity between the variant inflation factor.
Having passed a couple of diagnostic tests mentioned previously, we will now look at the correlation analysis and test the significance of the variables used. The scatter plots below have been constructed on eViews to visualize the relationship between the dependent variable and each of our independent variables. The plots between log consumed with log income and log EXRT appear to be upward sloping. This indicates that there is an imperfect but positive relationship between the variables. On the other hand, the plot between log consumed against INTR is downward sloping, which indicates that there is an imperfect and negative relationship between the variables. The tables here are an extension of the scatter plots, which shows the correlation results between the dependent variables and the independent variables. On the far left, we can see that log consume has a strong and positive correlation with log income because the Pearson's R value is 0.9829. The figure in the middle tells us that the correlation results between INTR or interest rates and log consume is strong but negative since the Pearson's R value is negative 0.8643. Lastly, the figure on the far right shows that correlation between log EXRT and log consume is 0.5677, which shows a positive but not necessarily strong relationship between the variables. Now let's test the individual significance of each independent variable, whether or not it has a significant effect on our dependent variable. To do this, we have conducted several one-tailed t-tests. So if we look over here, our degrees of freedom is 27 and we will test the independent variables at the 5% significance level, hence the alpha value of 0.05. Having identified our degrees of freedom and alpha value, we can then derive the t-test critical value from any one-tailed t-test table to obtain a value of 1.703. Now that we have our critical value, we must decide whether to conduct a right-tailed test or left-tailed test. Looking at our hypothesis, we will use a right-tailed test to test the significance of log income on consumption. On the other hand, we will use a left-tailed test to test the significance of INTR and log EXRT on consumption. We begin by looking at the t-stat for log income. Since the t-stat is 15.3338, we reject the null hypothesis at the 5% significance level because the t-stat is bigger than the critical value. So in the right-tailed test, it falls in the rejection region. Therefore, it can be concluded that log income has a significant effect on log consume. Next, we look at the t-stat for INTR, which is negative 1.1429. In this case, we do not reject the null hypothesis at the 5% significance level because the t-stat is bigger than the critical value. So in the left-tailed test, it falls in the non-rejection region. Therefore, we conclude that INTR has no significant effect on log consume. Lastly, let's look at the t-stat for log EXRT, which is negative 2.8634. This means the t-stat is smaller than the critical value in a left-tailed test, so it actually falls in the rejection region. Therefore, we can conclude that log EXRT has a significant effect on log consume. Okay, so the last test we have conducted is the F-test to check what the overall significance of the model is like. So if we look over here, our first degree of freedom is 2, while our second degree of freedom is 28. We will conduct this test at the 5% significance level, hence the alpha value of 0.05. Having identified our degrees of freedom and alpha value, we can then derive the F-test critical value from any F-test table for 5% significance level to obtain a value of 3.3404. So now that we have our critical values, the decision rule is to reject the null hypothesis if the F-stat is larger than the critical value. From the figure here, we can see that our F-stat is 346.6879, which is much larger than the critical value of 3.3404. Therefore, we can reject the null hypothesis at the 5% significance level and conclude that log income, INTR, and log EXRT all have a significant effect on log consume.
Hello, it's me, Mama Akmal again, and now I will be talking about policy recommendations. Our first policy recommendation is monetary policies. One common approach is to lower interest rates, which makes it cheaper for households and businesses to borrow money for consumption or investment purposes. This can lead to an increase in production and jobs as well as higher wages. The second one is flexible labor markets. It helps to ensure that workers are able to find jobs that match their skills and abilities, and that businesses are able to fill vacant positions in a timely and efficient manner. A flexible labor market is one in which there are few restrictions on hiring and firing, and in which wages can rise and fall in response to changes in demand. The third one is social security. A well-designed plan of social security measures such as old age pension, unemployment compensation, and employment insurance can provide stability to the working class. The fourth one is fiscal policies. Redistributive fiscal policies like tax transfers to poor households can assist them in spending for education or health. The last one is wage and income policy. A long-term wage rate increase policy can aid in enhancing wage earners and salaried people's consumption schedules.